Okay, so there was an example that we got in class that looked like this for our answer. So, um, obviously, this is not an output that is on the unit circle. If I would have said cosine theta equals root 2 over 2, we would have said, oh, well, I can look at the unit circle and see that happens at pi over 4, and then dot, 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 dot. That also happens at 7 pi over 4. So those would be my two solutions. Well, again, let's specify theta is from 0 to 2 pi. I drew that horribly. 0 less than or equal to theta is less than 2 pi. So there is no good way to represent what we're about to do. But really, let's break this down at least a little bit. So really, these are two numbers that's happening right here, right? There's the plus and there's the minus. Now, 3 plus the square root of 13 over 2 turns out to be bigger than 1. We can do that on our calculator. It's bigger than 1. However, 3 minus the square root of 13 over 2 is some negative number that is greater than negative 1. This is between 1 and negative 1. So this is in the range of cosine. So I'm going to erase the plus minus because we only care about the minus now. And now we want to figure out what angle could possibly be plugged into this value to give me this output. Well, what did we talk about before that takes an output for cosine and it gives you the input? So what did we do before that undoes our cosine function? That is cosine inverse. So theta is equal to just cosine inverse of this horrid number. Now, this is something that our calculator can give us exactly, but the only way that I can give this as an exact answer is just by leaving it like this. But we need to specify something. Cosine inverse is a function, aka it has one output. This is going to be one number. It is a number in a very specific part of the unit circle. So if we draw, let's ask ourselves, what is the restricted domain that we did to get cosine inverse? And we said that that's 0 to pi. So it's the top half of the unit circle. Well, cosine inverse is going to give me an angle that is about right here. But there is another angle for the same x value of minus, or sorry, whatever this negative number is. There is another angle just directly down here, right? We can draw the line that is x equals this horrid number, and it goes through 2 points. So there's two answers from 0 to 2 pi that we need to figure out. One of them is this one in the blue on the top part of the unit circle that is the cosine inverse. But we need to figure out how to get this other number. Well, I can describe these numbers in relation to each other and that I know they are the same distance from the horizontal line, from the x-axis, aka in this case, they are the same distance from pi. So the difference is that cosine inverse is that number less than pi. This number right here is less than pi, whereas this number down here is this distance from pi, but greater than pi. So how do we find the distance from our cosine inverse to pi? I just do pi minus cosine inverse of 3 minus the square root of 13 over 2. And this is this distance that we needed to find. So now my second angle is going to be this distance, but that much greater than pi. So I need to start with pi and then go forward this much, aka pi plus this number, which once we see we're doing pi plus pi minus this just turns into 2 pi minus cosine inverse of 3 minus the square root of 13 over 2. So this is my angle in this quadrant, whereas this is my angle in the second quadrant, so on the top part of the unit circle. So, yep, there turns out to be no better way of writing these than just saying that theta is cosine inverse of 3 minus the square root of 13 over 2. And theta is 2 pi minus that number, cosine inverse of 3 minus root 13, all over 2. So this was the way that I knew we could solve it this way, but I genuinely thought that there had to be some approach that was cleaner in some sense than this. Maybe more direct, more approachable. But I think this is fine in some sense. It's just pretty messy in the terms of you had to kind of pull on this idea of our inverse functions, and you had to think about their restricted domain, and then how to find another angle from there. Blah blah blah, the geometry of it all. And again, this was pretty specific to the fact that we were talking about cosine and cosine inverse. Because what if the question would have been sine of theta equals 3 minus root 13 over 2? Now we're talking about sine inverse, but its restricted domain was in the top part of the unit circle from 0 to pi. Its restricted domain was from negative pi over 2 to positive pi over 2. So we'd have to account for that difference there, and that it would give us an angle right here, maybe, but is the domain that it's asking me for and even in the negatives? Or when it says from 0 to 2 pi, am I supposed to take this number and move it forward one period? So again, you just have to be very careful thinking about the domain of our inverse functions and how that relates to the domain that is asked of us, and how many answers that should include. Okay, so this was my review over these. I don't want to be too negative and emphasize again that it's kind of painful, but a little outside the box, roundabout, pulling a lot of different things from a lot of different places approach. Okay, so yes, this is part 2 and pretty much the last part of this chapter that I wanted to go over.